Today's Zane debates topic is one I didn't think I needed to make. Is the Earth flat? This isn't about mocking anyone or winning an argument online. Science doesn't work by insults. It works by evidence you can test yourself. So instead of opinions, today we're going to look at measurable, repeatable observations. No space agencies required. Just physics, geometry, and reality. Let's test the shape of Earth. Around 240 BCE, a Greek scholar named Eratosthenes performed one of the simplest scientific experiments ever conducted. He knew that at noon on the summer solstice, the sun shined straight down a well in the city of Zane, meaning no shadow formed. But at the exact same time in Alexandria, hundreds of miles north, objects did cast shadows. If Earth were flat, sunlight would hit both locations at the same angle. But it didn't. By measuring the shadow angle and distance between the cities, he calculated Earth's circumference with remarkable accuracy. Within a few percent of modern measurements, no satellites, no modern technology, just geometry. This experiment still works today, and people repeat it every year. Next observation, ships at sea. When a ship sails away, it doesn't simply get smaller until it disappears. The hull vanishes first, then the mast, then the top. If Earth were flat, the entire ship would shrink evenly into the distance. Instead, the ship gradually disappears bottom first because it's moving over a curved surface. You can verify this yourself with binoculars, or a telescope at the ocean, or a large lake. Magnification brings the ship closer visually, but it never restores the hidden lower portion, because it's physically below the horizon. Now consider time zones. Right now, somewhere on Earth, the sun is rising, somewhere it's noon, and somewhere it's midnight. On a flat Earth with a nearby sun, sunlight would spread differently, and we wouldn't observe clean global transitions between day and night. Instead, we see a consistent moving boundary called the terminator line, the curve separating day from night, exactly matching predictions for a spherical planet rotating in space. Airline routes, global communication systems, and astronomy all rely on these predictable rotations, and they work precisely because Earth is round. Here's a question rarely asked. Why does down always point toward the ground no matter where you stand on Earth? In Australia, people don't feel upside down. Neither do people in North America or Antarctica. Gravity pulls matter toward Earth's center of mass. That only works naturally if Earth is approximately spherical. On a flat disk, gravity would pull objects toward the center of the disk at an angle, meaning people near the edges would feel sideways gravity. We do not observe this. Physics matches a globe, not a plane. The strongest scientific conclusions come from agreement across different areas of science, and Earth's curvature appears everywhere. GPS systems rely on spherical geometry corrections. Satellite orbits follow gravitational physics, predicted for round bodies. Lunar eclipses always show Earth casting a circular shadow on the moon, regardless of orientation. Southern hemisphere stars rotate around a different celestial pole than northern stars. These observations come from independent measurements made by thousands of scientists, engineers, pilots, sailors, and amateur observers worldwide. You don't need to trust an organization. You can test many of these yourself. So if the evidence is overwhelming, why does the flat Earth idea still exist? Because human intuition evolved for small distances. The Earth is enormous, about 25,000 miles around. Curvature over short distances is subtle, so our everyday experience feels flat. Science often reveals truths that intuition alone cannot detect. The Earth feels still, yet it spins at over 1,000 miles per hour at the equator. It feels flat, yet geometry shows curvature. Reality doesn't depend on what feels obvious. It depends on what can be measured. So let's summarize using testable science. Shadow measurements prove curvature. Ships disappear hull first over the horizon. Time zones match a rotating sphere. Gravity behaves exactly as expected on a globe. Astronomy, navigation, and physics all independently agree. Every measurable line of evidence points to the same conclusion. The Earth is an oblate spheroid, slightly flattened at the poles, but undeniably round. Science isn't about belief. It's about predictions that keep working no matter who performs the experiment. And for over 2,000 years, every successful prediction about our planet has relied on one model: a round Earth.